Hello, can everybody hear me this morning? Just checking. I think everyone can hear me. Julian, can you confirm? Sorry, just making sure all here. Good. Okay, well, good morning, everybody, and it's a real pleasure to be here and speaking at Generation Hydrogen's event. My name is Christopher Jackson. I am the CEO of Protium, a UK green hydrogen energy company, the chair of the UK's Hydrogen and Fuel Cell Association, and co-host of the Everything About Hydrogen podcast. I am absolutely delighted to have this opportunity to speak to Steve Heaton from Star Scientific. Steve, I think you're still with us. If you can turn on your video so that the audience here can see your lovely face. Are you there, Steve?
Can you read me? Hey, there we go.
Fantastic. There we go. So it's an absolute pleasure to have Steve with us on the call this morning. So for this discussion, Stephen, just kind of kicking us off, maybe you can talk a little bit to the Generation Hydrogen audience about Star Scientific's Hero product. What actually is it, and why is the Hero product relevant to the opportunity of decarbonizing heat with hydrogen?
Sure, Chris. Good evening, everyone, or good morning, depending upon where in the planet you are. Our Hero technology is a catalyst. It's a material that performs the catalytic oxidization of hydrogen, which sounds a bit technical, but in short, it is a material that facilitates the joining of hydrogen and oxygen, in return for which you get really high quality heat and water, the other output, pure water. So yeah, that lends itself to a very wide range of heat applications.
But I mean, I guess the obvious question for many people these days is, when we're talking about decarbonization and we're talking about net zero, some people would just say electrify everything. So, in the context of heat, why would you look at hydrogen in the first place for heat as opposed to electrification? What was kind of the thinking behind Hero that's, I guess, taking that different view?
I suppose, yeah, there is an electrify everything, but if you look at the use case, if the use case is heat, then you have to kind of go a roundabout fashion to generate the electricity in the first place, which is typically done with heat, and then you pump it across the wires, and then you turn it back to heat at the other end. So under those circumstances, Hero can be a much more direct route in that sense, and yeah, it's more efficient, I suppose, in that sense.
Sure. Well, I mean, yeah, more efficient, though, I guess, is an interesting question, right? So when we talk about decarbonization of heat, maybe I should take a step back and give people a little bit of context for the audience listening this morning. So, according to the International Energy Agency, 50% of all energy consumed in the world is heat. And obviously, that is a huge number, and a huge number that we need to decarbonize. And generally speaking, if you are, again, looking at the IEA statistics, around 20% of that heat portion globally is renewable, and actually half of that is really biomass. And I don't mean wood chips that you put in a power plant. I mean, people literally using dead branches or animal dung or other things to create heat in homes or for cooking. So, but when we're talking about efficiency, then I guess one of the things that people say is, why not use heat pumps? Why not use electric boilers? If we're going to have to create large amounts of renewable electricity anyway to create renewable hydrogen from electrolysis, why not cut out that efficiency loss, and why not go straight to it? What is the benefit of going to that higher heat that Star Scientific can offer with Hero? What is the specific challenge that you're resolving there that a pure electrification solution cannot?
In terms of the actual heat generation, it's the start point and the end point. So if you want to wind it that far back, you can use the Hero technology in power production. We're already demonstrating really high quality steam output of demonstration devices. At that point, you can use Hero from the get-go to generate the electricity. Again, I don't think we've got time, Chris, to dive into the joys of synthetic inertia generation, but I suppose I like to think of Hero as the unconventional thermal generation, if you like. So in existing coal-fired power stations, for example, you've obviously got big spinning turbines. Electricity grids love that technology because it's a big spinning mass, and that gives you lots of smooth electrical power production. So you could potentially take the Hero technology, take off your coal-fired boiler, bolt on the Hero technology. When you think about it, the turbine downstream doesn't care where the steam comes from, as long as you're giving it the quality and the quantity that it needs, then yeah, you can produce your electricity right from the get-go with Hero as the heat source. Use it to produce steam. There's some really exciting possibilities. And again, we don't have time, I'm sure, to jump into the joys of supercritical CO2 turbines and the like. But yeah, just in terms of good old James Watt's technology, we've been doing that a while now, and steam turbines are really mature. So yeah, we could start with that. We can move that all the way through to the point where the Hero technology, again, being a heat source for power generation, lends itself really well to islanding, for example. Now, if you're off the grid, if you're beyond the poles and the wires, then the Hero technology scales really easily from really small to really large scale. So yeah, you could take yourself off the grid in that sense.
I mean, obviously a huge range of applications we get in there. I mean, maybe something that I think, you know, this is meant to be, you know, encouraging a generation to think creatively about hydrogen technology. So maybe, sure, you know, you're talking about hydrogen for heat. I'm going to be slightly controversial and say heat probably isn't a topic that most people think is very sexy or glamorous. And I would say often people have thought that, you know, with regards to hydrogen, when you're generally talking about it, people are thinking about transport, thinking about planes and supercars and various things. So, you know, what makes Steve Heaton turn around and go, I really like the idea of doing something with hydrogen and heat? What kind of inspired you to look at that area? You know, what sort of drove you down that route?
I suppose, Chris, if you want fun enough back, we weren't actually chasing a zero carbon heat source. The origins of Hero was on another project, Star Scientific's foundation project's actually muon catalyzed fusion. And we sure don't have time to talk about that today. But
oh, well, that's a shame. I mean, that probably
well, hey, maybe next time, sure.
Maybe next time. Sure.
So yeah, we had a zero carbon heat source. It was literally the combination of, at that time, deuterium, which is heavy hydrogen, exposed it to the atmosphere and got this really interesting phenomenon, which was actually a bad thing as far as muon catalyzed fusion was concerned. And we chased it. Is so much of science is, it's not so much a eureka moment, it's a what the moment. And it wouldn't go away. And eventually it dawned upon us that, hey, this is a really useful heat source. So what can we apply heat to? So again, northern reaches of the northern hemisphere, not so popular in the southern reaches of the southern hemisphere, but district heating is a really good example. That communal heat idea through to a staggeringly breathtaking wide range of industrial applications. We're being approached by a lot of industries at the moment going, hey, could we apply, you know, Hero to our application? I suppose is a very short cross-check, if you like, is, yeah, if you're burning, you know, natural gas, if you're burning fossil gas at the moment, then, yeah, there's a very good chance we could apply Hero to those same circumstances.
Sure. I mean, I guess the interesting thing to think about a little bit here is also around scales, right? I mean, you know, I like the fact that you're describing this as kind of something that you've almost discovered in the lab, right? And I guess that's something that often when people talk about a lot of hydrogen technologies, they assume that they're very large immediately and can work on very large applications. But most applications at the moment, if you can see this, are kind of this sort of size. This is, you know, one of the Horizon fuel cell sort of little toys that you can buy, but they're quite a good way of showing the size of them. So, you know, how do you scale something that you discover in a lab like the Hero technology and get it to the point where, you know, beyond being an interesting phenomenon that you can observe, it actually is something that can replace, you know, a 800 megawatt or even a several gigawatt coal-fired power station as the source of the steam production, which, as you then say, the turbines themselves don't care, but actually it's the steam generation piece. How do you think about that scaling? How's that, you know, even come together when you're thinking about applications?
Sure, Chris. I suppose from our point of view, the Hero catalyst is a surface reaction, and therefore it's surface area driven. So if you have a very small surface area, then you can generate a small amount of heat. If you want to spin, you know, a few 720 megawatt turbines, well, yeah, that will require an awful lot more surface area. But again, we've developed a really interesting active side heat exchanger where it will take the Hero reaction on one side, transfer that into the working medium, whether that be water, obviously produces steam, or CO2, if you like. And yeah, it's a matter of just upping the surface area to get the scale of the heat that you need to match the application.
I mean, you make it sound so easy, Steve. But you know,
yeah.
But I mean, you know, let's, you know, I'm going to keep pushing on with this one in terms of scalability, because, you know, when we're thinking about how do you facilitate energy transition, how do you actually allow these new technologies to really decarbonize? one of the challenges of scaling is actually, as much as anything, the logistics of it, which you're describing, surface area, things like that, and heat exchanges. And the other is actually just thinking about things like, how do I get people comfortable and familiar with this technology, and how do I actually get them to the sense where they feel that it's going to be reliable? So, yeah, how...
Sorry, Chris, I seem to have lost you. One of us is frozen.
You can have that impact.
Okay, sorry, Chris, you dropped out there for a second. Could you repeat the question, please?
Okay, I think I got dropped. I think
3 times lucky.
3 times, yeah, 3rd time's a charm. No, so trying again. How do you get new customers comfortable with a technology like yours when you're trying to go from what you've observed in the lab to that kind of commercial scale? How do you build that confidence with those end users that your technology can do what an ordinary boiler or other heat source can do today?
Sure, Chris. And again, I'm sure you're more people aware. Typically referred to as crossing the valley of death, getting it from lab actually out in front of customers. I suppose what's really encouraging at the moment is that governments worldwide are embracing hydrogen as a zero carbon energy carrier, heat source in our case, obviously, and a lot of them are coming forward to support financially, logistically, even regulatory support as far as getting hero technologies out there. So they're really encouraging early adopters to step forward. And yeah, Star Scientific's already in negotiation with like I said, a truly breathtaking wide range of organizations of all scales in terms of looking at their potential applications. So in terms of getting the comfort, the Hero's been used on vast bulk scales for, a few decades now, if you think about it, as far as ammonia for fertilizer production is concerned. So yeah, it doesn't get an awful lot of press. It doesn't have very high visibility, but there is some really mature and some, for want of a better term, expert knowledge as far as dealing with huge quantities of hydrogen is concerned.
So I think where this kind of then leads to, in my mind, is, you have this, obviously you do have a few people that are willing to do it, willing to kind of cross that valley of death. How do we, in an energy transition as fast as the one we're trying to accomplish today, accelerate that? How do we get around the inertia of, if I buy a boiler at home, that's supposed to last me 20, 30 years. So if I put it in, I'm not even thinking about replacing it. And industry is no different. I've built a brand new furnace or oven, I'm not sort of thinking anytime soon about replacing it. How do we overcome that inertia whilst also trying to cross the valley of death? What do you think we can do and people listening to this could do to improve that?
Yeah, I suppose, again, back to power production, you're right. If you look at what a typical coal-fired power station is invested in their turbine set, it's, tends to be hundreds of millions of dollars. So if the transition can be minimally disruptive as far as the actual, application is concerned, so much the better. But in coal-fired power stations, I suppose a really good example of that is it can be a really strong win. You don't have to worry about your locks and socks scrubbing. You don't have to worry about your coal handling, grinding. An awful lot of money spent on preparing the coal to actually go into a coal-fired power station. So there's a really strong use case for them. And I think, Chris, and again, obviously, generation hydrogen is a good example of it. There's an awful lot of attention in it as well, and people genuinely want to get on with it. So whatever we can do, whatever technology we've got going, it's a matter of, making people aware of it. Like I said, seems that a lot of the governments are on board and supporting it to help, facilitate the interactions between research and transitional science, if you like, into my favorite example is, we need to squeeze the science out of it and make it all engineering. Engineering's, is the real world solution part of it. And just make that a smoother transition and therefore a hopefully faster transition as we possibly can.
Well, Steve, I've got, I think, about a minute before we got to do the Q&A. So in that final minute, something that I wanted to ask you, and you've, quick response if you can.
Please. Yeah.
Can you give me a book or a particular individual who you find inspires you, or a book that's inspired you to think better or think differently about the problems that you're trying to overcome with Star Scientific?
Yeah, a vast range of books, but I suppose perhaps most relevant to this audience would be, I remember being given a book as a young lad called The Soul of a New Machine. I'm sorry, I cannot for the life of me off the top of my head remember the author, but it was about how a particular computer company was generating a new generation of chip, and their existing engineers were going, oh no, we can't do it, and it's all these, insurmountable problems. And the head of that lab went, you know what, I'm going to go and get a lab full of fresh, green engineers who don't know what's considered impossible. And yeah, they got on with it and solved it. So to me, I think that was really inspirational that, yeah, sometimes just, again, there's obviously a balance to be made. You can't throw away the wisdom, if you like, but sometimes a fresh approach with people that don't know what's impossible can be a really positive approach to take.
Well, I think that's a great way to kind of segue into the question, Steve. So I'm going to go through question number one. So question number one is from Robbie Anderson. So Robbie's question is, would the Hero technology be applicable for heating for off-grid homes, or is it more for larger scale applications? I know you sort of touched on this. Maybe as you've done the larger applications already, Steve, you can talk a little bit more around, for the individual, so that kind of energy independence thing for individuals. How does the Hero technology work for that?
Sure, I wouldn't rule it out, but in terms of a heat source individually, again, the world is quite rightly focused on heat pumps in those kind of circumstances. So yeah, that's probably a better application. Hero won't be everything for everyone, but as far as I mentioned, the parts of the world that are keen on district heating, I know in the some Scandinavian countries, they actually have very large gas-fired boilers as backups. Yeah, no, don't do that. And I can't remember, there's a German word they use for an extended doldrum period. Yeah, again, if you're running those big gas-fired boilers for 3 weeks at a time, yeah, no, don't. As far as the Hero application is concerned, that would make a reasonably straightforward application, because those loops are typically already running at 60 degrees. So yeah, Hero would really kick hard from that kind of start point.
Yeah, and it's interesting. I think there was, I think they actually did look at catalytic hydrogen boilers for a school up in Scotland, for one of the ones in Orkney when they were doing the old green hydrogen project. So I know it's something people have looked at, but maybe with technologies like yours and an app, there's something more people can do. So go from one extreme to the other. I have a question from Mohammed. Apologies, I'm going to mispronounce. Tala Ahmed Ansar. So the question is regarding the glass industry. And I guess, again, this sort of is kind of the spectrum thing. So here, I think you talked about 700 degrees C, but a lot of industrial applications like glass, you need furnaces that are getting into the thousands of degrees. Is Hero then something that you see that's kind of the upper limit of what you can do, 700, and so there are just certain industrial applications that won't work? Or is this just kind of the first iteration of what potentially this catalyst can do, and actually with future iterations you may be able to get up to even those highest temperatures that at the moment are only met with coal and other fossils?
It's likely that we'll continue to refine the components of our catalyst to the point where we can increase the temperature. Again, I won't tell you what the upper limit is. It's a bit above 700, 800 odd. But yeah, as far as those kind of super high applications are concerned, especially ones that actually rely on radiative heat transfer, Hero's conductive heat transfer. Yeah, those kind of super high temperature applications, Hero is probably not the right solution for them.
Okay. And, I think, again, question number 3 we've got here is from Johannes Golden. The question, I guess, kind of being put here is to say, we're talking a lot, I guess, in generation hydrogen around a green hydrogen solution. Do you see a role for blue hydrogen applications? And how would you see a technology like Hero maybe sitting alongside blue hydrogen applications?
I suppose, if you like, from a bloody-minded point of view, Hero doesn't care where the hydrogen comes from. We're only running 3/9 purity at the moment. It's not ridiculously pure. However, part of Star Scientific's philosophy, and something I'm personally really keen on too, is, yeah, we'll go green. I don't want to belittle CCS. There's some interesting comparisons that could be made to, solar PV cells 10 years ago. The argument goes that CCU is kind of in a similar space at the moment, and with the appropriate focus and funding, maybe it'll come through. Yeah, it's too early, and I don't have the expertise in how that will work and how that's actually going to play out. But I suppose, yeah, electrolyzers are here and now. I've spent a bit of time speaking to various large-scale electrolyzer manufacturers, and their response is, look, we've got plans for massive electrolyzers. All we're waiting for is for the market activation. Well, Hero's technology applied to power generation, we'll be looking at, thousands of tons of hydrogen an hour. So in terms of market activation, yeah, I'm pretty sure we'll be able to get where we need to go with green.
No, and I think obviously there's a lot of people who would probably agree and align with that one. I'm just looking again through the question list. It's mostly, I think, focused on this kind of idea of should you be using hydrogen for low temperature heat? And I think we're back into the kind of residential discussion there, which is, and I think we've touched on before. I mean, something that I would like to push maybe a little bit on is, hydrogen for combustion. Like many things, you sort of don't want to be the only girl at the party or the only person standing in the room. So what are the other technologies that Star Scientific are seeing out there that are doing something different with hydrogen for combustion? And how do you think those are sort of helping or supporting your company to raise the opportunity and awareness of what hydrogen can do in this space?
Yeah, I suppose hydrogen for combustion, again, just to make it clear, there's no flame in Hero. It's a flameless oxidization of hydrogen. So that makes it rather unusual in that sense. Very keen, if you're going to combusting it, then yeah, sure. Got to be careful of the heat transfer factors of hydrogen. It doesn't, the flame temperature is hot, but its ability to perform work with that temperature is somewhat limited. Again, Chris, I don't think we've got time to dive into the vagaries of the physics behind that. But I suppose in answer to the second part, yeah, Star Scientific, I'm sure like an awful lot of companies in the hydrogen space are very keen to grow the hydrogen pie, for want of a better term. The more people there are using hydrogen, yeah, the bigger the market will be, and all of us stand to benefit in the hydrogen space.
But there isn't anyone that you're seeing that's also doing something interesting and similar. So that in that sense, kind of the idea of using a hydrogen catalyst for heating is quite unusual. You haven't seen someone else that you're looking at. It's also interesting, because I think these are interesting. I think everyone always asks, why are you the one company doing this, or why are you the one?
Yeah, I suppose, Chris, to put it in really simple terms, our patent says we're the only ones that are doing it.
Well, that's a good answer.
So in that sense, but again, like I said, I don't want to make that sound flippant or arrogant. We're genuinely keen for people to grow the hydrogen pie. The more applications there are for it, yeah, the better off we'll all be for the hydrogen economy.
So, Steve, there's a good question on this list that I actually think, someone could say is a stupid question, but I think it's a good question. It's from Holger Eisenlohr, which is, can you actually describe what Hero looks like? Does it look like a sponge or a foam? How, if I'm visually trying to imagine what this thing looks like, can you maybe give us some details?
Okay, if the technology allows me, I believe I can actually pull up an image of the Hero catalyst working.
So you got 2 minutes, so this might be the last one, is this?
Yeah, there we go. Hopefully you can all see that. Yeah, that's our demonstration apparatus. It's not doing any work. The thing that's glowing orange is the Hero material. Yeah, it's basically, it looks like a metallic surface. The white thing that it's standing on is a thermal insulative pedestal, and the wire that you see coming off the top isn't providing any kind of energy. It's actually a thermocouple, which is a temperature monitoring source. So yeah, that if you're curious what it looks like, that's what it looks like. Again, I strongly encourage you, go and have a look at the Star Scientific website. We have a video of Hero actually starting live, and you can get to see, we're over sort of 700 degrees in less than 3 minutes. So yeah, that's a good example, if you like, if people want to dive deeper into it.
No, I think that's fantastic. And one of the other questions we have here on the list, and probably one of the final ones, Sebastian Schmidt's just asking a little bit about kind of how long actually does this system last for at the moment. So, you've got the system, you've shown a couple of pilots, how long in the lab does this one last for?
Yep. Great question. Obviously, we're doing formal longevity work to work it out. But again, it's a genuine catalyst. It only facilitates the reaction. It's not used up in the reaction. And I suppose my favorite example, that photo I just showed you of the demonstration apparatus, that's been running now, geez, it's got to be close to 3 years, hundreds of demonstrations. I actually had my co-inventor of Hero Technology, Sam Kirk, very talented chemist, prepare a backup sample just in case that one failed. And yeah, we haven't had to use it yet. It's going strong.
Fantastic. Well, look, Steve, on behalf of everyone from the Generation Hydrogen team, thank you very much for going through this deep dive on hydrogen for heating with us. It's been an absolute pleasure. And I think we are moving on to the next session. Thank you, Steve.
Thanks, everyone.
So I believe now I'm going to be told by trusty Enapter colleagues on this call, Julian and others, that we're moving on to our second session, deep dive. Julian, are you going to introduce across, or do you want me to dive straight in? I'm going to take silence as potentially a cue that I should be setting up the next one. Julian, do you want to come in?